One will take money in an account that compounded continuously at 5.75% interest to double. So I'm going to start with $1 and I want to double to $2. And then that's E to the RT, so 0.0575, and we're looking for T. Oh, this is already 1, so I can just take the ln of both sides. Ln of 2 equals 0.0575 T. So T will equal ln of 2 divided by 0.0575. And with my calculator, I'll find out that that's 12.05 years for that amount in the account to double at 5.75% interest. Now, half-life. The idea of doubling time, which we just did, is related to half-life, or the amount of time it takes a quantity that decays exponentially to become half of its original amount. So carbon-14, known as radiocarbon, is a radioactive form of carbon that is found in all living plants and animals. After a plant or animal dies, the radiocarbon disintegrates. Scientists can determine the age of the remains by comparing the amount of radiocarbon with the amount present in living plants and animals. This is called carbon dating, and the amount of radiocarbon present after T years is given by this equation, where Y sub 0 is the amount in living plants and animals. Let's go ahead and use that. So suppose we find the skeleton of a woman who lived in classical Greek period was discovered in 2005. Carbon-14 dating at the time determined that the skeleton contained 3/4 of the carbon-14 of a living woman of the same size. Determine the year in which the Greek woman died. Well, here's my equation again so I don't forget it. We know that she ended up with 3/4 of the radiocarbon. Well, let's just use 0.75, that's 3/4. And my Y sub 0 will be 1/2, the carbon. That would represent the amount of carbon for a living woman of the same size. So we'll do 1 e to the negative 0.0001216 T, where we're looking for T. This is a 1, so I can just find the ln of each side. Ln of 75 hundredths equals negative 0.0001216 T. So T is going to equal the ln of 75 hundredths divided by negative 0.0001216. Grabbing my calculator, I find out that T equals 2,365.8 years. And that's 2,365.8 years ago from when this body was discovered in 2005. So if I take 2005 and subtract how many years ago that was, I'll get negative 360.8 years, or instead of calling it negative years, it would be 3,600.8 years before the common era. And we can estimate when that person died.